So, quick brief thing. Independent events that kind of, they don't influence each other. Like, you flip a coin and then you roll a die. Not connected. But dependent events is somewhere where you're like, you have 10 socks, chances of you pulling out a blue one, right? And then the second event is you don't replace the sock you pulled out. So now you have different number of socks, chances of you pulling out another blue one, right? So that's sort of dependent. It depends on when you pulled out the first event, because that'll change your probability for the second one. But there's a really simple hard and fast rule so I actually have this website. It's linked down below in the video. But there's some examples. The first few are actually pretty good, but you'll scroll. Don't freak out about it. Some of this goes like super into depth, and then there's like disjoint. Like, we don't need to know that, but very key right here. If PA times PB equals PA and B, then A and B are independent events, otherwise they're dependent. So, why did they put this here? Probably to confuse you. Because you see that, you're like, I don't know, right? But basically, 0.4 times 0.6 equals 0.24, meaning that this is independent. That rule, hard and fast if you think about it, because probability, you multiply them together for the chances of both of them happening, right? Pretty simple. But if they like sort of rely on each other, then you can't just multiply them, and it gets like more complicated with like factorials and everything. But this is basically saying you just multiply them together if they're independent events, which they are. And I think we did this. I want to say we did this year too. But yeah, that's the hard and fast one, is if they multiply together, independent. If they don't, dependent. And then there's a second problem. So, independent, we figured that one out. Yeah, and the reason is because of this. Because literally what I just said, where this times this is that. That's not true. No. And generally you don't really add probabilities. It's not really, so if your reasoning is you're adding them, like, probably not the right one. This one, this, if you think about it, like, that's not likely. That's probably not the reasoning. And so this one has, like, I guess you could kind of do some like logic, but yeah, the reasoning behind it is just independent. And then the website's a great resource. So yeah.